Good morning to everyone. We'll now move to part 6 of Heron's formula. Application of Heron's formula in finding areas of quadrilaterals. In the last video, we practiced some examples. Now I am sure that all of you will be thorough with Heron's formula. In this video, we are going to discuss about application of Heron's formula in finding area of quadrilaterals and also prove a property of triangle. So, there is also going to be an example here. We will apply this Heron's formula to triangles, split the quadrilaterals into triangles and then find the area of quadrilateral and also prove a property of triangle during this process. So, use of formula for triangles. We already discussed in quadrilaterals chapter and earlier in triangles chapter about the importance of learning about properties of triangles. In this part and next part, we will see some practical examples from which we can understand further the use of formula for area of triangles. Just I am only again telling you the importance of geometry. Basically, if it is like we have initially learned the properties of lines, angles, basically that is for the properties of triangles, and triangles properties we have been using for quadrilaterals, and similarly now the area of triangle we will be using to find out the area of quadrilaterals. So, this is example 4. Kamala has a triangular field with sides 240, 300, 200, 360 meter where she grew wheat. In another triangular field with sides 240, 320, 400 meter adjacent to the previous field, she wanted to grow potatoes and onions. She divided the field in two parts by joining the midpoint of the longest side to the opposite vertex and grew potatoes in one part and onions in the other part. How much area in hectares has been used for wheat, potatoes and onions? 1 hectare equal to 10,000 square meter. You can note down this question as it is, but in the next page we have got the drawing. Let's see the drawing and then we will proceed. Yes, so the drawing is given. So there are, you can see now there are three triangles. It is actually a quadrilateral. It's a concave quadrilateral which you may remember in the quadrilaterals chapter we saw. Here A, B, C, E, D. Why it is concave again I will tell. You may remember when you will say a quadrilateral as a concave, when one of its diagonals is outside the quadrilateral. If you see B to D, it comes like this. So, the diagonal is outside. So, that is why it is called a concave quadrilateral. Anyway, you need not bother about this. I will remove this. This is just for information I told. Now we will see some samples. So, there are three triangles you can see: ABC, ACE, ACD. So, let us proceed with the example what it is there. We have to find areas of triangle ABC, ACE and DEC. Because in ABC it is wheat, in AEC, ACE and DEC onion plus potatoes have been grown in equal areas. So, as per the question it is ACE and ECD are equal. So, all three sides are given for triangle ABC. You can see ABC we have got all three sides, but for the other two triangles neither the third side nor the height is given. Correct? So, you can, I will just explain to you further by showing in this. So, this is one side, this is one side, this is one side. This is for triangle ABC, correct? It is given. So, for AEC or DEC, we do not know the dimension of EC. So, therefore, we are given only the triangle dimension, triangle ACD dimension is given. So, let us go forward and see. I will remove all the markings. Since EC is a median of ACD, EC divides triangle ACD into two equal parts, that is area of ACE equal to area of DEC equal to half of area of ACD. We will see the proof for this later in this part. Why a median divides a triangle into two equal parts we will see at a later part, but for a moment what is there is, so this equal to this. So, ACE, triangle ACE equal to triangle DEC and both are equal to half of the triangle ACD. So, that is the presently what is given. So, let us now Go to the next page and see how to find the area. Therefore, we have to find the area of ACD, for which all three sides are given. Now ACD, all three sides are given, 240, 320, 400, it is given. So once we find that, we can divide by 2. So now you can pause the video, note down the steps. This is for triangle ABC wheat. Same thing, whatever we have discussed in the last 1, 2, 3 examples, same is there. You can see the step. I'll just put a tick for you to understand. The first step is here, perimeter, that is semi-perimeter. S is found. Next step, formula, substitution, multiplication, cross-check, factorization, grouping, and then taking the numbers out. You can see. And finally, the final answer, I have also multiplied by root to 1.414, so 22,627. And in the question already it is given 1 hectare is equal to 10,000 meter square. So with that we have arrived at the answer. Area of triangle ABC, that is wheat, is grown in 2.26 square meters, hectares. I'll remove all the markings. So you can note down the video and pause the video and note down all the steps. But otherwise you also know, you can do yourself and then find out whether the answer is matching. Now we'll go to the next page. Again same, this is now triangle ACD, all steps are same. And then finally you can see at the end, step number 3, area of triangle AEC equal to area of triangle DEC equal to 3.84 divided by 2, 1.92 hectares. So you can pause the video and check in your notebook, with your notebook, whatever you have done and whatever is there here, both are matching. We'll go to the next page. So therefore area used for wheat is so much, potato so much, onion so much. So for steps we have already seen in the last 2 pages. In step 2 we can write the factors of 10 also. Just for your information, again I am writing in every place I am showing, so that in case you have confusion you can see why it is like this. You should not get confused why I have not taken factors for 10. There is one more point. ABCD is a concave quadrilateral, as I told in the beginning. We divided this into 2 triangles, ABC and ACD, and found their areas. Area of quadrilateral ABCD is sum of the areas of these 2 triangles. A quadrilateral can be divided into more than 2 triangles for finding its area. So we can also be divided into more than. So here it is already shown as 3 triangles, but since the in between dimension is not given, we have found the area of 2 triangles and then found the total area. So the point is here, for finding an area of a quadrilateral, if you are able to divide it into a number of triangles and in between dimensions if you know, then easy to find the area of quadrilateral. Otherwise there is no other formula for finding area of quadrilateral for such type of quadrilaterals. For rectangle, square it is available, but for any random quadrilateral it is not available. You have to only divide into triangles and then find the area. We'll go to the next page. So median of a triangle. What is the median of a triangle? A median of a triangle divides it into 2 equal parts. Let us see what is the median of a triangle. This is actually the point here. Median is a line joining midpoint of one side to opposite vertex. So here in the diagram, S is the midpoint of PQ, R is the opposite vertex. So SR is the median. RS, therefore RS is the median of triangle, and area of RSP equal to area of RSQ. So there are 2 triangles, you can see RSP and RSQ, both the areas are equal. So we are going to see the proof for that. The proof is again very simple. Once I write, you will be able to understand. Draw a line from R to T such that RT is perpendicular to PQ. Now RT is perpendicular to PQ. So immediately if a base is drawn from, a perpendicular is drawn from the base, you will know what is that. We discussed in the earlier part. Yes, it is the height of the triangle. RT is called the height of both the triangles. So even if it is extended, if you see RSP, the height is outside RSP, but still if the base is extended and a perpendicular is drawn, that is the height of the triangle. So SQ for RSQ, that is the base, and PS for PS, that is within bracket PT, for triangle RSP to the opposite vertex. So from the base of both the triangles we have drawn a perpendicular line to the opposite vertex. So RT is the height of both the triangles. So this is important. You can note down the definition median as well as the height as well as how we have drawn in this, how we have arrived at this. We'll go to the next page. So we can see here area of triangle RSP equal to half PS into RT. So PS is base, RT is height. Similarly, area of triangle RSQ equal to half SQ into RT, the same thing. But PS equal to SQ. S is the midpoint of PQ, correct? So I will just put this, you will know PS equal to SQ, correct? So next point is therefore area of triangle RSP equal to area of triangle RSQ, because only PS and SQ are different. If you see the first line, you can see this and this are same except that PS and RQ are different. So PS equal to RQ, therefore both the triangles are equal. Thus proved a median of a triangle divides it into two equal parts. The two equal parts are, now if you see this PRSP, I am sorry, I'll just remove this, I'll again put this, yes, up to this only, no, and this side. So these two triangles RSP and RSQ are equal. One important point you can see here, two equal parts need not mean that they have to be congruent. So these two triangles are not congruent, only the areas of both the parts are equal. So because there is one common side RS, but the angles are different, the PS and SQ are also equal. PS is equal to SQ, RS is common, but PR and RQ need not be same. If they are same, then they are congruent, but they are not same, but the areas are equal. So that is why a median divides a triangle into two equal parts. Now you can note down the steps and then go to the next page. So in this video, we discussed about application of Heron's formula in finding areas of quadrilaterals, that is by dividing it into two or more quadrilaterals, and also proved a property of triangle, median divides a triangle into two equal parts. Also understood what is meant by median of a triangle, that is line joining midpoint of one side to opposite vertex, and height of a triangle, the perpendicular line from base to the opposite vertex. So you should not get confused between these two. Median means it is a midpoint of the base. So the line need not be perpendicular, whereas the height means it is a perpendicular from the base. Here it need not be the midpoint. So median is a midpoint, whereas base is height is a perpendicular. So very important. So you have to remember this point, and accordingly you should use whenever there are examples. In the next video, we will discuss about application of Heron's formula in finding area of quadrilaterals. So some more examples we will see. 5 questions are there. Pause the video, note down, and then proceed. And that's all for this video. Thank you.